I'll get started. So my name is Mikko and I work for Intel, but I'm also been one of the maintainers, contributors to the CNCF confidential containers project, and I'm trying to give a lightning talk with 6 or 7 slides in 5 minutes. So let's see how it goes. So I guess if anything. If anything, try to remember our project logo, because this is what you can find from the CNCF landscape website. So we are a CNCF sandbox project, already 4 years in the making. So let's get into it. So when we talk about confidential containers, we also have to talk about confidential compute. So what is confidential compute? So confidential compute really adds data protection while it's being in use. So using certain hardware platform capabilities, you are able to run your code and data in trusted execution environments. How these trusted execution environments are built and what your trust boundaries look like when you deploy something is really important. So without confidential compute, your confidential data can be vulnerable to multiple adversaries on the platform. Whereas with technologies like confidential virtual machines, you can build CPU-protected virtual machines in such a way that many of your host admin adversaries are outside your trust boundary. What's this one? Yeah, I guess it's this one. So put this previous slide into a concrete example. So on the left-hand side, I have an untrusted platform admin doing a virtual machine memory dump and trying to search secrets from your virtual machine memory, and they can perfectly do so because none of the VM memory is being protected. But with confidential VMs, you try to repeat the same. You won't be able to find anything because the CPU transparently encrypts the VM memory and won't find any secrets from your deployments. Why confidential computing is important? Maybe it's not important if you're just running a web server, but if you're dealing with privacy-sensitive data with personally identified information, or if you're working with regulated industries, this is really becoming a requirement. One concrete example is this EU Digital Operations Resilience Act, DORA, that became effect in this spring, that essentially requires you to handle data encrypted all the time, which basically implies confidential compute. So enter confidential containers. What we really try to do is take your existing cloud-native deployments and run them using confidential compute with pod-level isolation, meaning that all your pods are being isolated in their own protected virtual machines. 2 additional goals we have. One is we want this to be like hardware vendor agnostic. So there are multiple hardware vendor providers that provide similar capabilities, but we, in our confidential containers project, want to hide many of those things. And one last thing is that we are building additional services that you can verify that these confidential VMs are really your confidential VMs. We are working on, besides the feature development, we are working on blueprints for many important and useful use cases like confidential AI, private prompts, model parameters, and of course this whole trusted, secure software supply chain with your signing keys processed in CVMs all the time is important. What we also want to hear, what is your cloud-native use case that could benefit from confidential containers? Community, we have CSPs, hardware vendors contributing we have our own GitHub org, CNCF Slack, of course, weekly meetings, and so on. And the other thing besides the logo is remember our website. So you can, from the website, you can find a lot of information about like architecture details and also steps how you can give the project a try yourself. Thank you.
Hello, guys. So my name is Andrey Maltsev. I'm a senior cloud native engineer at AlphaSense, and my talk will be very light and kind of a short. So basically, we will be talking about the FinOps and how to really minimize your Kubernetes costs and well, the cloud costs, but not just like do the proper like sizing of your resources. So well, literally. The problem statement, the possible solutions, and well, the Q&As will be outside of this room. But anyway, so that is a very simple example. What we may have, like some developers develop their Helm chart for their application, and if they see the OM event, what's like its OM killed event, they literally just simply do the multiplication of their CPU memory usage, like from 2 to 4 and whatever. So, and that brings us to the situation where we have like a very overcommitted resource utilization. So literally like that, like 548% of the CPU requested compared to the actual usage, but well, 260% of the memory. And some solutions what you may apply, and not just like read something, but really apply and like start using even now, it's those, like the Goldilocks, for example, or the Robusta KRR. And also there are like some manual checks what you can do, like literally just go into your cluster and like, what that application is using. And also there are a few services that really may help you to reduce the costs. So the Goldilocks, for example, that's the one of the things what we are using at AlphaSense. It's the service what you can like deploy to your cluster, which will like analyze using the virtual pod autoscaler your usage of your services, like the pods, and drop it down to like the namespaces or wherever, and it just show you like you probably have to reduce or even like increase your CPU requests or limits. Same with the memory. And well, you can write some CI/CD optimizations, for example, or even an operator within the Kubernetes to like read those details and just optimize your pod manifests. Another thing which doesn't need any like VPAs is that Robusta KRR, very interesting thing. So you literally can just run that command, like run the Robusta KRR in your cluster, and it will give you that brief information about your commitments, like CPU requests, limits, or whatever, what you can adjust. We're also using that in our pipelines. And it's literally just looking into the Prometheus and taking the data you already have. So no need of the VPA there. And you can use some tools, literally, like an OpenCost, which is an open source project for the cost monitoring for Kubernetes. The only thing what you need to do is like literally configure it properly and do a proper resource like tagging. But also it's using the Prometheus compatible API, so you can just call it wherever you want. It's literally very usable, but there are also some options like, that's just an example of the dashboard there. Also, you can use the KubeCost. It's an IBM product, but it's almost the same as an OpenCost, but with a few more features. That's also kind of like the similar dashboard there. Another thing is a FinOut. It's the tool what we are using, but it's mostly for like an enterprise-grade like companies, the big ones, but they have a lot of interesting features within the FinOut, and they also have almost the same kind of a dashboard. ScaleOps, a very nice tool I actually have seen on a KubeCon. They do the same thing, but automatically for you. Very interesting thing. Probably some of you may like to test. And there are also FinOps stuff who's doing the same, but with AI enabled there. And yeah, that's something like that. Well, and that's it actually, because I'm running out of time. Yeah. So any questions you can ask me in the room later. Yeah. Thank you.
I think everyone by now is convinced of the concept of internal developer platforms. I tell you, it's the new black. But you don't have to take my word for it. You can listen to the software industry. According to the Accelerate State of DevOps report from 2024, 89% of the respondents have some sort of internal developer platform. We have this idea of empowered, streamlined teams who can focus on delivering product value, all thanks to our amazing developer platform. Finally, we can be fully DevOps. What could possibly go wrong? My name is Jessica, and I've been working with platforms for the last 8 years. And I will here to share some of the learnings I've gathered from when platforms doesn't work out the way you expect them to. So you're building your first platform. Congratulations. You set out on the journey. Who do you bring with you? So you probably pick the people that are knowledgeable about the problem that you're trying to solve. They are probably already hired in the company, they have a lot of experience, and they also bring their backpacks. And you want them to start solving the problem. And you might hear things such as, it's faster if I just do it. And this is the first red flag that you have to be on the lookout. Because if you have to do it, you have the wrong abstraction, and your developers are not empowered. And suddenly, you're the ops team again. But we want empowered, enabled DevOps teams. So don't be the ops team. You will soon find that people start looking at you in a funny way. Like you should solve anything they would rather not. And we need someone to build, own, fix this thing. Surely it's a platform problem. In Sweden, we have this word, slasktratt. It's where you throw all the things that you don't want. As a platform team, you're at risk of becoming the company slasktratt. You own all these things. Oh, and by the way, please build a platform. And in the end, you don't have time to deliver on the platform because you're busy taking care of all them things. So don't be the slasktratt. As continuation on the slasktratt problem, it's easy to fall into the trap of solving every use case. And we like helping people. We want to solve the problems. So we have 99 problems. Let's build a platform that solves them. We now have 101 problems. Because as everyone knows, in software, off by one is a very common error, even for AI. In the end, you have a platform that doesn't really solve the problem. It's hard to maintain, it's slow to expand, and you have more problems than you started with. So don't solve all the problems with one solution. We all heard about build it and they will come. Being an expert on a subject matter, it's easy to fall into the trap of not doing enough customer research because you already know what they need, right? So when not doing customer research or customer discovery, you end up solving maybe the wrong problem, or you solve the problem in the wrong way, or you're not matching the company workflows and processes. And in the end, you have a platform that doesn't solve the needs of the developers. Best case, you can adjust your platform, and worst case, you have to start over. But now you lost a lot of trust with the organization because you did not deliver what you promised to deliver. So don't build what you think they want, build what they need. Okay, honesty time. How many in this room is currently in some sort of migration? I expect every hand in the air at this point. Because it's hard to build an effective abstraction of a platform. And it often leads us to having to migrate when upgrading or changing the platform. So how do you avoid bringing your developers on migration after migration? You spending trust with your organization with every migration and so on. The migrations adds up and your teams might be in the process of several migrations at once. But by investing some extra effort in making those migrations smooth and fast, you remove work from the teams and decrease the amount of time and concurrent migrations they have to work on. So don't die the death of 1,000 migrations. You can avoid these pitfalls through empowering your developers to own the full application lifecycle, to have a clear vision of what problem your platform is solving, aim for the thinnest viable platform, at least as a start, and focus on a user-centric platform and treat it as a product, and spend that extra effort on a smooth and fast migration. And if you succeed, everyone becomes a happy potato, because I like potatoes. Thank you. I'm Jessica from Trice. Thank you for having me.
Thank you. Yep. I'm here to remind us that, as you all know, S in Kubernetes stands for security, and I'm here to remind it is not. I'm Ashish, and another Swedish giant. I work for IKEA as Security Engineering Manager. Before this, Abdul was talking about Ray, and during that he said the Ray doesn't have the authentication on the dashboards, and then the port forwarding can expose some other things, so the security has to be, caveat. Well, he stole a couple of my slides. I wanted to talk about the real life incidents which I have seen in the production, which basically, exposed APIs, non-authenticated dashboards actually being exploited by someone who found them out, right? Secrets, leaked secrets, people found them out on the public GitHub repository or in some other ways, and then they exploited to actually get into environment, and then exploited some other things like RBAC configuration, and then gain access onto the whole Kubernetes clusters. This impact which you see right here is very minimized. Once you have the access onto the Kubernetes clusters, you can do way more things than just running crypto mining. Crypto mining is something which you might all have seen at one point of time or another. And one more thing, once you have a secret leak, statistically, once you have a secret leak happen, it takes only between 5 to 11 minutes. I was telling it to somebody today. It takes between 5 to 7 minutes while that secret is leaked, and that it starts being exploited in the wild. So that's the reality. I'm here to remind that what are some of the things which we should do. Absolutely start focusing on your logging. You need to know what's happening inside your cluster, inside your containers, you need to know. And absolutely two things, exec and port forward requests, they are attackers' favorites. Monitor them. Real-time monitoring is also important. Manage your secrets like nuclear codes. Doesn't have to be kind of a special message on that. Secrets are everywhere. These are some of the places which remains in the Docker container environment, but secrets are everywhere in your Slack, in your Teams, in your Confluence pages. Secure them. Container images, another things which we need to start securing and start kind of caring about. If you don't already have a secure base images or container images registry, which is providing your developers secure and verified images, something needs to change. Absolutely, for these Kubernetes configurations, we have many tools available now, but these Kubernetes configuration checks are available, and that needs to be run before you push anything into the production. Yep, these are some of the known security misconfigurations which can be something. So please ensure that you don't have these misconfigurations. These are very basics. I have seen more incidents with these basic misconfiguration in the production environment than anywhere else. Wow, 1 minute early. Thank you so much.
Cool. Let's see. Yeah. Next up, let's continue on the security track and talk about access control. So I wear 3 hats today. I'm a master's student at Aalto University. I am a staff software engineer at Upbound and an organizer of this conference. So access control. What is some common paradigm to kind of think or formalize it? So one way to formalize the most basic question is that can a certain principal, so a user, access or perform some kind of action on a given resource R, and often in some specific context C. So this is called the park model. This is, of course, just a tip of the iceberg and the most easy abstraction between the thing that takes the decision, so like what computes if someone should have access or not, and the thing that actually enforces it. And you should be separating these two. But of course, there's a lot more that we don't have time to talk about today, like querying permissions and analyzing them and similar. So if you don't separate, so if you don't follow the kind of park model and you just make an API server, like you start out small, it's easy, like you have an endpoint and then you're like, yeah, I have an admin, right? So I put the first one. If it's not an admin, then I do access denied. Then you come around and, oh, I have some owners in the system for some resources. Well, I add another check. Then on and on and on. And then finally you have lots of if checks that you don't know really what's doing. Like, I guess you can't really super easily see from this code what has happened. And maybe when there's a new endpoint, you need to duplicate this to some other place. And also, because this is Turing complete code, you can't analyze it. You don't know what is actually going to happen with this code when you run it up front. So in access control generally, there's this kind of balance between expressiveness and being performant, being safe, and being analyzable. So this tug of war between the two extremes is always there. And on the expressive side, you have full, if you write in a programming language that is shown, and the most simple kind of other mechanisms are on the other side. So what is in the middle? Can we strike a compromise? So this talk is about, lightning talk is about CDAR. It's an Amazon open source project, and this paper I highly recommend from them, detailing the design. And basically, it's a language, an authorization library or engine that lets you write declarative and analyzable access control policies. So for example, in the previous example, you have typed principal actions and resources. So you say that if the resource is a list and then it has an owner, then if the principal is the owner, then they can access. If they are in the team admin, a relation-based access control, then they should be able to access. Or if they are a reader or an editor of the resource, they should also access. So this is much clearer. You can kind of see it by just looking at it. Now, what is better is that you can start analyzing that. So what does that mean? CDAR is open source. It tries to strike the balance, and it's meant to be donated to the CNCF in coming weeks, hopefully. So 3 things that I think are unique about CDAR is that, well, you have a typed schema. So you have entities, users list, for example, and they have certain properties or attributes. And if I now typo this editors here, then VS Code shows that, well, this policy doesn't make sense. There's no editors attributes on the list. And I can easily see like syntax highlighting and auto-completion and stuff like that when I write. I never knew I needed this so badly before I started trying. Another analyzability thing is, well, I have an old policy. I tried to make a new one and refactor things, but then I ended up with a one-off error or something like that. I thought they were the same, but I didn't know. So that's helpful if it just tells me that this policy is not the same as the old one. And did you mean that? Finally, there's a lot of rigor put into this library, which I really respect, which is that they fully kind of formally verify the whole engine using mathematical code, and then check that is it the same by automated testing. So I've been researching CDAR and its integration with Kubernetes. I think CDAR has a potential to unify the CNCF ecosystem access control. And tooling matters. I mean, how many were using containers before and after Docker? It's a difference. Thank you.
Okay, they put the French guy that speaks too much at the end. That was a smart move. Well done. So I had an idea that was to basically explain what I've seen in the service mesh world that year. I have a TLDR. I now have gray hair. You can maybe not see it. But another one I want to explain a quote from one of my favorite philosophers. That's also what French people do call Sartre for people from Finland. He said that the difference between a tool and a human is basically in the essence. So when you build a tool, you have the essence before the existence. Yeah, we do philosophy right now. Which means that when you create something, you know what you are creating, and that's why this thing exists. So an example, if I want to create a screwdriver, I know what a screwdriver is before creating it. I have a reason for that. I know what I'm solving. And humans are a little bit different. Humans come into life, they exist before they have an essence. You don't know what you're gonna do, right? My mom didn't know I will be there today. But something I've seen in Service Mesh, but also in other tools in Cloud Native, but especially in Service Mesh, is that we are doing it the human way. We are building stuff and we have no idea why. We are building products that have no essence, and there will be a little bit of that today. So let's start. Where is the timer? Okay. So first, big news this year, new version Linkerd, protocol declaration. So for those who don't know that, basically what Linkerd does is that it guesses the protocol that your application wants to use with something called protocol automation. So basically they know what you need. The issue with that is that sometimes it takes too much time, and basically if you can set up the protocol at the moment your service mesh starts, it crashes. So now you can define your protocol. GitOps compatible multi-cluster linking. I think that was a big thing. This year, all the service mesh provider worked a lot around multi-cluster. So now you can handle all of the declaration through GitOps way. Gateway API decoupling, keep that one in mind, important for the next slide. So basically by default, when you deploy Linkerd on your cluster, it comes with the gateway API specification. So all the CRDs are there, but now we will not. So you will have to install the CRD on your own. And big news also, experimental Windows build. Big thing in Service Mesh last year, everyone is trying to put and embed Windows workloads. So Cilium, for example, is now pushing eBPF on Windows. Maybe you heard about that. Linkerd is pushing that also on Windows. And Ambient also said that Ambient Mesh will be working with Windows containers. So big news. Now, something interesting, if you remember last slide, is like, when we look at Gateway API specification, so if you haven't heard about Gateway API Mesh, you should look at that because that's the new way of doing Service Mesh. Since last year, we have now two projects that completely support the Gateway API Mesh profile, which are Cilium and Istio, and not Linkerd. So there's a quote from the previous slide that's interesting. So if you do Cilium and Istio and you use Gateway API, you can now just migrate your Service Mesh in a few lines of code. So pretty good. Istio Ambient Mesh, if you haven't heard about it, the idea is to go sidecarless. And now you need to remember 2021, when everyone at Istio contribution submit was basically laughing at people doing serverless. But now, sidecarless, now they are sidecarless too. And it's now a general availability, so GA since 1.24. If you haven't heard about zTunnel, you should look at zTunnel. I'm going to talk about that in the next slides. So now the big question is, if Istio is going sidecarless, is it the end of the war, right? Is it the end of the war, sidecar versus sidecarless? Well, it's not. So we also get new numbers last year. Also on the Linkerd side, they did some comparison, sidecar versus sidecarless, called numbers matters. You know, this company are owned by men. So the idea was to compare the 99% and to see who was the fastest. And still, for some use case, sidecar are still providing the best, I would say, speed at the 99th percentile when you have enabled MTLS. So it's not the end. I think sidecar are not going to disappear. What I love with sidecar is that at least I know who the bad man is, if that makes sense. Like when something goes wrong, at least I know where to look at. Where when there's no sidecar, now I'm stuck. Something new also that was recently announced, and remember, I told you to remember about zTunnel. Cilium is now going to support zTunnel. So now the war is very interesting. So the TLDR is Istio pushing ztunnel to do MTLS sidecarless, saying that the best numbers are done thanks to ztunnel, so not thanks to Istio. So now people at Cilium are like, okay, maybe we could use ztunnel too. So now MTLS is coming inside Cilium, supported by ztunnel, which is provided by Istio community. So I think that was very interesting. And at the end of my talk, there's lots of new interesting network announcements. You should look at it. And that's it. That's it. Yes.